Got it. Good man. Yeah, quick nosedive just to take the start there. BSides K-Man, thank you so much for having me back again. 3 years in a row and still back, so that's good. I love it. I'm going to talk about IoT today from a broad perspective down a little bit to kind of, how you can get our arms around it, how we need to deal with this thing. I'll talk a little bit about scope. I'll talk very specifically about the perspective from a retail side and from healthcare, if everyone's good with that. I will delve into more automotive just briefly in terms of what I see and what I've dealt with, because that is a very key area that is going to be very interesting. And one of the examples I have for when things go bad is the 2015 Jeep Cherokee debacle. So I will touch on that just briefly as well. Again, appreciate you having me here. I love this little, meme there. Classic meme picture, but just rendered for today's sort of world. It's the thing of like, okay, so everything talks to everything these days. To the point of literally had a conversation outside with Andy from eShore, and we're talking about IoT, the prevalence of devices, how many things we have in our lives today that record data that are functionally significant to us in terms of inputs and how we can share this information out to our partners, our third parties, that we deal with, etc. The example he shared was, for example, his cat feeder. So while he's away, he's based in Jamaica, he can look in Kingston and see what the status is on the cat treats right now. And if he needs to, he can hit the button a few times and pop a few treats out and the cat's happy. Amazing simplicity in technology. But the question mark, of course, from the security guy's perspective is like, what else is that device doing that we don't know about? And what else is it talking to internally or externally that we don't know about? And that's, once we start getting into those sort of questions, things get really interesting, of course. So let's dive in a little bit. The broad perception is that, IoT is rife with issues. There's all sorts of simple things that are wrong with these devices. The examples, of course, default passwords, weak and insecure web interfaces, weak and insecure cloud infrastructures that we communicate through these things through. Insecure mobile interfaces on these things. All of these, of course, proven. There's legion examples for these things being the case. Authentication failures and issues, and lack of encrypted communications. I would extend that on, beyond that into backdoors, intentional or otherwise. We're seeing more and more these days in terms of foreign states adversarially attacking OT devices. Right, the current referencing that's been in the media for the last 2 weeks is that the Chinese alone have 600,000 personnel. That's a 50-to-1 ratio versus what the US currently has in defense. There's 600,000 odd personnel that are on the attack side for that. If you look at the two most significant threats in OT, in terms of what we've seen from Russia and what we've seen from China in terms of the campaigns and the persistency and what happens, those two vectors, those two sort of adversaries are coming hard to get control of OT and IoT devices. Interestingly, we do also see some, sort of somewhat friendly nation states every now and again pop up. One of those I'll reference is the Swiss with what they did with the camera systems a couple of years ago. So part of the issue we deal with here is prevalence, right? 50 billion devices and growing. That's the part I'm saying about getting your hands around this space, right? So it's enough if you think about, like, I'll give you my own personal example, right? I'm not wearing it now because it's busy charging, but I have an Aura, which gives me all my personal health stats, right? So that's, as a device, that's already just, it's a wearable, it's giving me all my data, it's communicating through an app on my phone. So there's cloud storage, there's, on-device storage, there's a communication path between the Ring, my device as the transit device, and the ultimate, application resident in the cloud for the processing and the return of data to me. And I assume that all of this is great and wonderful, and it's not going to cause me a problem. But that's just one device. I have two lots of camera systems at my home. One is a Ring doorbell. The other one are a series of cameras throughout the house with key spots that I wanted to monitor. I look at the smart TVs, I look at the fridge, I look at stuff that we have in the kitchen that has some sort of sentience, if you want to look at it that way. And what we're dealing with is a myriad of devices which are performing function for me, which give me some remote capability, some ability to communicate with other parties should I allow them to. And that's the key message I want to put in there is, please, if you're going to use anything that's OT enabled, IoT stuff, please understand what the communication paths are. if you have the capability, please look at your network at home, see what's outbound, see where it's coming from, understand the relationship between that smart TV and its update server or the providers of streaming technology that you draw as a function. Because not everything is what it would seem in there. You need to be very careful with these things. Classic example, IPTV is incredibly popular in Canada now. It's nothing to do with the overcharging that the regular providers have. It's just because people are from other countries, other regions, they don't have the facility to get their regional TV capabilities other than IPTV. So you have these little Linux distro boxes that are out there that are performing this function. They connect to all kinds of different stuff other than just the streaming component. So if we look at it from a business perspective, though, office technology, monitoring of office technology, in office, in space, that's obviously a very big thing. A lot of stuff around production today. The advent of RFID as a measuring function and a reporting function, obviously within storefront and supply capability, took off dramatically about 20 years ago. And that's really changed the whole landscape to the point that you look at these, the new Amazon warehouses where people are essentially absent and the devices perform all the functions in sort of drawing stuff and packaging stuff together. And that's where that leads. So that supply chain piece has been a huge component of the IoT conversation. Retail and hospitality, again, the old days of having my bartender come into work, mount the bottle with the little tot measure on there and give me a shot from there. That sort of stuff's gone because maintaining what you had and what you needed to order from that stuff was just time consuming. When you have measurement technologies today that would give us the ability to measure that tot, it's exactly a tot that goes out there. So if it's a single or a double shot, it gets measured out exactly, and that references instantly down to the database that tells us where we're at in terms of stock. So we're not running out of rum and brandy and gin and what have you when BSides is in town. And you look at sort of the school landscape, hospitals. Hospitals are a massive one. I will touch on that very specifically because I've got one that I'm dealing with at the moment that's really, really interesting. And then state and local government, of course, everything that's within there, including the protected infrastructures that you would have for ICS and SCADA and how they relate to the overall practice as well. If you'll bear with me 1 second, let me talk about the hospital one because that's interesting. IoT encompasses a lot of different spaces, and what's happened is as technologists have looked at the space and try to figure out how they can address the security aspects of what you'd have within these different areas, we've seen specialization. So companies have come out whose specialization is in these specific areas, right? And so medical, as an example, the medical IoT thing is essentially considered a sub-practice of IoT these days. There's enough companies there that are servicing just that piece, which is interesting. I'll give an example. So Sick Kids Hospital in Toronto as my example. They're busy rebuilding their entire campus, right? So they're about a 40-year-old infrastructure currently across 6 different buildings. They're going to collapse that down and rebuild a number of them. And so the new towers essentially will come online from 2028 forward. And just one of the examples that was shared with me by their CISO, they're looking at a 20-story building there where the intention is to have every layer of is functionally every floor of that building run almost like a home device, like as a home network, right? That's the HAN approach. Within that, though, they're looking at the total for the building will be 52,000 sensor devices that will operate within that infrastructure. So you think about that in just one building in a campus, the new campus will be 4 buildings. That's one building of 4. And the amount of information that goes through those infrastructures, like at every level and then shared across the stack and fed up to the cloud and to their data center as a backup infrastructure. Getting your arms around that, maintaining the security of everything that's going to happen within there is going to be an enormous task. Right? That's one of the reasons we're having, this conversation started last year. So we take a 5-year view in terms of where are we today with IoT and medical IoT, and what do we need to get to? What will we build out that'll be significant then and need to understand for then? Right? How do we handle that volume of information? How do we essentially cascade it down to those individual levels, right? And then extrapolate the data up so that those that need to see it can see the entire picture. It's not a trivial architecture. It's really quite exciting, quite interesting. I'll just reference the retail one just briefly as well. I'll show you an example later from the retail space, from an industry organization in Canada that's building out retail space in a very big way, and their intent is to have everything smart and enabled. Their biggest building is out in Burnaby, BC, but overall they've got 40 million square feet under management. And what they're intending to do is have all the core functions that you would imagine within that device, from security, from IT, all the operation stuff, all the critical operation stuff that goes within those devices, to the lighting systems, public addressing, everything needs to be IoT and needs to be OT enabled. And the security of all this stuff is giving them a lot of headaches. So again, the architecture that you need to build in around that has been incredibly interesting. And I'll show you the model that Andy there has developed, which is kind of a maturity model for the entire industry in Canada to embrace, so that they can get into OT and start, embrace the IoT journey and having a good measure of how things can be done. So a couple of really good examples. I did take this slide just straight from Zen Armor, to be fair to them. That's why I kept the badging on it. This is a great reference, right? It just shows you a couple of things over time. So if you look at the examples here, 2010 Stuxnet. I'm sure most people have read Kim's book. They know what went on there. For its time, foundational stuff, really interesting. The ability to essentially remotely get those devices to spin faster than they were intended to, so that we can ruin their access and destroy them. Pretty interesting stuff. The first botnets that came out, right, where the majority of the botnet was IoT related, and all the different devices that were incorporated in there were essentially beaconing out and connecting to other devices and spreading things. So the first time we saw this really going far. The third example, that Jeep Cherokee example, right, where changing the radio essentially impacted device function, right? The accelerator function goes away, right? So by touching the radio, the thing was infected enough that it would take away the accelerator, right? Very, very dangerous. Not like, this is not, it's, as a proof of concept, it's quite a worrying thing that you would see. I actually just read something last night that, so the UK was the first country in May of this year, May 24, 2nd of May, they put out their first draft of legal protection that is required by technology companies that want to supply IoT. So any connected devices, any IoT-related stuff, in the UK at least, has to account for how things are secured and how the users will be protected from those devices and from misuse of those devices. You look at this example here, and you see what's happening in the vehicle space. This is a very, very critical thing. So the article I read last night unfortunately didn't give any referencing and sourcing on who they were quoting and what was going on. But the principle they were discussing was, in bitter and contentious breakups of relationships these days, how more and more people are leveraging connected vehicles as a way to get revenge on their ex, which is like, that's really leaning into it a lot, So yeah, just beware. Mirai in 2016, obviously, another great example that was very public, very well understood. Went across, again, a whole series of different devices and took advantage of those things. The St. Jude medical device stuff in 2017, again, proof of concept that leaked out into the wild. And the ability within those to start fiddling with pacemakers and things along that lines that have a material impact on people's lives. Again, just sounding the alarms for what should happen. So my call out there is, you look at that. So that's 2017, and then 7 years later, the UK, as the standalone country in the world so far, has put together just even the draft of legislation of what you should be dealing with. And we talk about 50 billion devices. So you'll see that the problem we're dealing with is the technology leads, the protection comes after, as always, and then the legislation is always way behind, right? So as a practice area, for those that are here from government, it's probably a good idea to have a lot of conversations and get into some depth with people that are involved in this space and start figuring out what we need to do and how we could help anybody that needs to in there. Looking further on, 2017 in Reaper, 2021, the second iteration, 2020, the second iteration of Mirai, and then 2021, the Ricardo example, where the Swiss got in there, backdoored their camera system, and were able to cause a lot of havoc within that. So just a couple of nice examples, just some things to sort of put things top of mind. So that's the bad side of it, that's the issue, that's the problem side. Let's lean a little bit to the other side and start looking at the solution side, what we can do, how we should think about these things. And this slide, for those that will read it, goes top, left, to the right, and down and across again. Key things about IoT, discovery is number one. But we have to know the devices that are out there. What we don't know, we can't protect, right? So we have to know what the devices are, what their state is, in terms of like currency, etc. So have all that stuff classified and codified and recorded in some way that's meaningful to us. We have to understand the device communications, how they're supposed to work versus how they actually do work. Right? That sounds a bit silly, but if for those that are practitioners, you'll understand what I'm saying there, right? Things are supposed to go across specific ports. Updates are supposed to work a certain way, et cetera, and then things get deployed, and then you suddenly have weird things going on, and you start realizing, there's a problem here. Once you have the discovery, once you understand the communication paths, then only can you start looking at it. And this is zero trust conversation from last year's conversation here. Then only can you start embracing the zero trust approach and start locking things down, right? Doing your segmentation, validating least privilege access is what that should say, I apologize. Validating that you're applying least privilege access to everything that you have going through there. From there, continuous monitoring, right? So we've defined what the device is, communication path is set, we set segmentation in place. Now we validate that we're actually doing it and nothing changes. Because it's in the changes that things start happening to us, right? Who in this room hasn't had an issue with a change that someone else did and did or did not publish successfully that caused you pain? Oh yeah. There's my people right there. You know what we're talking about, right? It's the router update that happened last night that suddenly causes the problem with the mail server that nobody could see coming, but nobody knew about, et cetera, et cetera. I'm in the firewall space a lot, and it's always the firewall, and it never is the firewall. It's always the other stuff, but hey. Yeah. Simplicity of operations, and looking at, once you have a handle on this, once you start looking at your policies, you start figuring out your monitoring, you get a handle on what's coming through, you start feeling quite comfortable about this, you can then start leaning into automation. And automation is what starts making it real. That's when you get the 50 billion devices and put it down into a structure that you can actually get a handle on and actually start running. So from an operationalist perspective, you can start breathing, you can start realizing, yes, we're well classified, we're well structured, we've got protections in place, they are effective. You start grouping logs and alerts into functional bits that we don't have to look at everything and start bringing our window down in terms of what we're going to react to. And that's when the team can start getting a handle on things. So getting to the automation workflow is a critical piece, and I'll detail that in a bit more as we go along. For those that were here 3 years ago, when I was doing the conversation about how the SOC is dying and how automation is going to take over a lot of that function, that's what we were talking about then. That's still what we're talking about today. This is common. This is a practice that is well established. To get to the next level, let's get into the operation stuff very specifically. What we want to look at here is, again, define the assets, look at the communications protocols, look at the access control that's applied around there. And for simplicity, you'll see a lot of product names around there. Those are just generically recognized as kind of the leaders in their space, right? A number of those are competitors of ours, and that's great. This is an OT conversation from a general perspective. This is not about, any relation to product at all. But what you'll see there is you start looking through the space here, right? So asset management at the top, network access control, start looking down, detection and response capabilities. You look down at your endpoints, network management piece, IP address management, vulnerability management. The one thing that's not on there that I would like them include in this vision is identity, right? Because it's identity for the person as well as for the function. And for those that need to understand the difference, function is an identity because it is something that performs a capability for us that we need to be aware of. So it could be a device, the code within the device that performs that function for us, I consider as a functional identity, right? The person that calls the device, that runs the applications, that do the things, identity as well, but these two things need to come together. But that gives us the ability to look at the space, look at the different technologies that may or may not apply. Some of those you may be familiar with, some you may not, and that's fine. And start looking in, what are the capabilities that you have in this scale now across the space that could start addressing these things for us. And so look at the integrations that are available between those technologies. So the very top example up there is great, right? I have an endpoint device. It registers that there's something wrong with what's going on in that within that registry maybe, and it needs to communicate out. And it'll tell its host management function, but if it tells ServiceNow as well, And ServiceNow can automatically create a ticket for me that'll get associated to the correct team that'll go back and fix that for me. And we can automate that piece so that we don't have 6 people doing these things. Now we have a person that can reference, oh, I've got a ServiceNow ticket. I can check the path of what's come through, where it came from. I can look at the management system, go to that endpoint. It is a problem, and let's fix it. Amazing. Automation's going to win it for us. We just have to get there, and this is like an example of the path. Once you have that, you can get into automating the workflows, and that's when I'm talking about the collaboration between the different technologies that are applying there. So if my endpoint technology can tell me that when something's going wrong, and it can talk to the switch, the router, or the firewall to involve the NAC, and the NAC can, as a function of policy, put things into quarantine, block them until we can remediate, and then again communicate with ServiceNow and the other pieces. And again, this is where the identity should come in, including the identity source, and again, remediate and lock out that identity while we figure this out. That again gets us to a state. So if the IoT devices that are unmanaged, where this is important, is we need to be able to validate what's going on in those IoT devices. Right? Healthcare example, infusion pump, it's monitorable to a certain degree. It's not going to get updated too frequently because while that thing works, everyone says leave it alone. Because the last time we did the update, the whole floor went down. We couldn't do the operations for that day. Everything got backed up. Everyone has a nightmare. We're never going to touch these things again. Of course we have to, but it means our change control and the process that we apply to those things has to be that much more structured, and the stricture that we'll apply to why we're doing that is going to be at a level that we've never seen before. So workflow automation and IoT, where that applies, ties those things together for us to give us the sense that we have some continuity of action across those different spaces, and then labels new use cases to come up. Because if we're doing that well, and a new device comes into scope, that'll get flagged immediately, because of course our policies typically wouldn't allow that. Right? So even if we know we need those pathways, we're going to create the policies that will allow these things through, structure our workflows so that these can now be accommodated. If that thing is wrong for some reason or is not operating as we'd expect, we'll see it and we'll know. Really key importance. Equally, again, for medical IoT, where device updating is not that frequent or that encouraged, the ability to look into that and see when things change. Right? So again, my infusion pump that was running version 4.02 performs a certain way and it updates a certain way. Well, now they just upgraded the encryption keys on that device. So what used to work from a windowing size now no longer works. Now, these things aren't updating anymore. They're not talking to anything. Why? Well, because the router that's up ahead of it isn't set up to handle packets of that size. Right? And we only know that when this stuff starts flagging. Right? So there's a lot that can go into these devices and a lot that can go into these flows where we can start paying attention to things once the automation is feeding that through for us. And then again, the ecosystem, you can have an extensive ecosystem. You can have 40 million square feet under management. You can have 52,000 sensors in a single building once you build out the ability to take in a lot of information, process it effectively, use the communications and automations that are available, and then then enhance those through things like SOAR technology, etc. And so that's where that leans to in the next sort of thing. I just put this one in because when you have these conversations, one of the things that comes up, everyone hates them, everyone's scared of them. They are a pathway, they are a capability, right? APIs are absolutely valid. There's millions of reasons why this would be a good thing for you. But from an IoT perspective, to rely on APIs to tell me what the device is and for me to do anything with the device in terms of updates, etc., we should be very careful about that. One of the things, again, with the 600,000 Chinese that are attacking things, they love this pathway because this and XML are not incredibly well understood. And so, a little bit of fun there, obviously, with, again, a classic meme. But API integration is the way to understand what's going on in there, not using the automations, the workflows, and everything that's available. Definitely a no-no. So if we look at what we have, let's look at an integration of workflow with an endpoint detection response, right? Extended detection response, and how that can accelerate your workflows. Marie, I think this might be familiar. What we need there is complete asset visibility, single pane of glass, potentially. Right? That's the ideal. Few people get to that in practice, but it is an ideal that everyone just works towards. And if you look at the bottom left there, we want to look at the device that we manage, as well as the other stuff like shadow IT and the shadow IoT and the other things that are completely unmanaged. We need to embrace the two views in our approach. Right? We can't have, and there are technologies out there that will only say, like, hey, I do medical IoT, I recognize these are my device lists, I'll have these 400 devices are recognized, and beyond that, it's like, good luck, we don't touch that stuff. Right? That point is not a solution for you, that's just a point product that does certain things for you. You have to be able to have a capability across this that handles breadth. Because there'll always be new, there'll always be adjustment, there'll always be change. So locked in, hard-coded, I only do these, specific counter things is not the approach that you want to be having here. So you have to have an approach to incorporate both of those things. And again, referencing to endpoint as a function within there is key. Right? Devices that don't look at the endpoint capability, and I'm not saying you have to have an agent on every single IoT device, but where possible, if you have some sort of an agent that can beacon to you, or have a sensor nearby that can reference the communication and beacon that to you, that is tremendously useful. So how we accelerate the SOC workflows. We need visibility into all connected devices, right? IoT, medical IoT, IIoT, and just IT ops functionally within there as well. So we have to embrace the entire landscape. Again, 40 million square feet of retail space, everything's in scope, right? We can't exclude anything in that. We have to have a holistic asset visibility. Again, we've got to recognize everything across there. Even if it goes back to old school DHCP beaconing that gets us, referencing for what that MAC address is, what the device is that's out there. We look at the logs for what's going through that sensor. We can see and pin down to, what it potentially is that's operating there, and can build a supposition that someone will actually go and validate. That's okay. Right? If it's got to be manual to get you started, totally fine. Single pane of glass to accelerate your SOC workflows. That again is the ideal, right? If we can have the feed up of information such that it's efficient, that it feeds up to there, phenomenal for us. And then where that leads to, SIM and SOAR integration. And again, referencing back to 3 years ago's talk, right, where I spoke about SOAR. The intent here is to have diverse workflows, diverse security inputs, right? All sorts of different log capability feed to a device structure that will give us intelligence, allow us to have reporting and monitoring and response capability around that. Right? So when you see these series of triggers that we think is this, how do we want to handle that? Right? What does the workflow say? What does the SIM do? Does the SIM communicate to me? Does it create a ticket? Does it flag? Does it create a war room so that everyone can jump in and we can then work the scenario? In the SOAR case, does it automatically remediate that for me? And why wouldn't you? If you're handling billions of alerts a day, why wouldn't you remediate automatically? Right. So IoT security, right? So we want out-of-box integration and capability. So we want broad integration, we want broad capability. We want a group and series of technologies that understand these things that can feed us that telemetry. From the telemetry, we want then the intelligence to pull these things together so our decision trees can present to us what the responses would be, and the SOC automation can be done within there, right, through the SOAR technology. Oh, bear with me, there we go. What that may look like, this is just an example, and this is it's a medical system specifically that I'm looking at here. Where we get device context, we can simplify resolution, and this example is again from the SOAR perspective. This is saying, here's the context that I'm looking for. These are the devices that I'm looking for. So these are the BMS devices that are beaconing out, communication as they're being used. Right? So the users are using them. We're seeing information flow. This is good. What we see in there is a visual representation of the devices, where they communicate to, what those communication paths go on to if there's a feed on from there, and what the volumes of data are, what any issues or threats or risks that we would want to call out can be done so in that sort of view. And then a breakout within that'll suggest things like device currency, device state, where the device is in terms of device identification if we have that tag for those. And what that allows is that we can then recommend actions to lower risk based on what we see. We can drill into those individual risk points and delve into it. Do a single-click integration, a single-click connect through to navigate down to what the end device is if we need to. The visualization obviously speaks for itself. It's a nice clean flow that allows us to see where things are going. And so this is kind of the end state of where we want to get to in our process of embracing all this and getting it done. A quick talk, if I may, just diverge slightly. So I spoke about medical IoT, I spoke about retail a little bit. Where things got interesting, I'm going to talk about this RECC. It's a working group within Canadian retail. Essentially, they've figured out they need to operate as an industry together to get their arms around the IoT risk and containing it. And so they put this RECC group together. There's the link there for anyone that may be interested. Andy Rodriguez is the guy that's driving this model within the group. So he's one of the leaders within the group. He is on LinkedIn, very good guy to reach out to. He's very open to talk and discuss with anyone that needs it. They're property tech specifically. So they're looking at, and I'll give you another example. One of the newest buildings they put up in Toronto, it took 5 years to build, was completed about a year ago. It's 7.6 acres. And they've got something in the order of 170,000 IoT sensors in that device, in that infrastructure. Again, everything from the lights to the security systems. Understanding the architecture that was required for there there was three different consulting groups that consulted on that, all of whom came to a consensus on how they would expect to build that out. And even then, 3 years into that, had to go back to the drawing board and redraw everything. Right? We had issues around power, we had issues around monitoring, we had issues around who would own the information. There's common areas for those projects which go. So like the building owner owns some of it is subbed out to the security organization, some of it's subbed out to other, like the lighting system, who knew, isn't owned by the building, it's owned by the people that are actually supplying the lighting on a contract basis. So every 2 years, they're contracted to come back in and update and refresh things, etc. So they own that infrastructure completely. There's literally a demarc on the electronic panel that's theirs, and then they go forward from there. Right? Stuff that nobody considered. And so that's where you get into these interesting things around, what are we going to do for them? How do we feed their information through the infrastructure that we're building to take care of all of this, such that they can perform their function, which we've contracted them to deliver for us. So it's not that we can say, like, go away, we're not going to do it. It has to be done. And so you figure these things out as you go, which is kind of interesting. That part about the stakeholders for industry is really quite something, because not everybody is equally understanding of how powerful IoT is and their part within it. So we talked to the guys that supply the security technologies, right? So the alarms, locks, smart locks, the cameras, etc. They're completely all over it. They know exactly what's going on. They can tell you ports, protocols, updates, frequencies, everything, like mean time to failure. Everything's well established. Again, we talked to the lighting guys. That's kind of not their thing. They don't really want to be bothered with it. You've got to hound them a little bit to kind of get the information and chase them to get it done. It's interesting, but this maturity model that we're trying to develop through that working group is helping set the perception of how things will be as we go forward, which is cool. On the automotive side, I'm going to start with the end one first, BlackBerry, right? Everyone remembers those. I'm sure everyone, above 30 at least had one at some stage, right? Everyone remember those devices, right? Once they changed from the wheel to the ball, it was rubbish, but hey, okay. I still miss the wheel. It was amazing. You could drive and type, not supposed to, but of course you do. BlackBerry today, the biggest piece of their business is in-car technology, right? They were a communications company. They bought an endpoint technology company to secure the endpoint. And they put together, essentially, their worldview now is they want to be in-car technology for every car they can possibly be contracted to deliver on. Phenomenal business change. Like, they will never be the communications juggernaut they were. Not to say they wouldn't ever be as big as they previously were. They're on their way back in terms of capability. But in terms of what they deliver and how they do it today, absolutely fascinating to see what that company's pulling off and what they can build in there. The middle one there, vehicular, is someone that's going to come at them very hard and compete. So this is a fleet management infrastructure that a guy by the name of RJ Khan in Canada has developed. And their intent is to take the old school fleet management and incorporate IoT within there. So understand, what's happening within those fleet vehicles. So where government, for example, what's happening within the buses, the trams, etc., that are on our streets. Where are they? How are they running? What are the state of those devices, like with everything within those? So, if the display screen's broken, we don't want to wait until that thing comes back and the report gets logged that someone will read in a week to go and fix the display. Know about it now. So in the command center for Toronto Transit, why not have that splash up and tell them display's out, right? Or engine's running too hot, oil's too low, whatever the case might be. That's where AJ is kind of pulling this stuff together to look at the fleet perspective and look at how you maintain the fleet as efficiently as possible by understanding as it go forward minute to minute what's happening with your fleet and wherever it is. So very cool stuff, and he's very security minded, so he's coming at it from the right perspective there. And then Geotab's another interesting one. Has anyone ever heard of Geotab? Kind of an interesting little project that 20 odd years ago, two South African brothers that came to Canada pulled. They'd done time in SA, understood GPS to a degree that like only the biggest nerds and geeks could possibly understand. But bless their hearts, they put together a technology around vehicle management that references GPS technology and the advances in GPS today as an IoT function to allow you to secure, like, where's my device, or where's my vehicle, how is it operating, what speed is it traveling, what routes does it go, right? So if the UPS truck goes back and forth on the street a few times looking for the house, that's a problem for UPS. They don't want that. And that software will tell them what's going on, right? Or the truck got stolen and it's somewhere else on the island. Who would know? That will tell us exactly where it is, what state it's in, etc. And so that has turned into a massive, massive business. The growth in that company is absolutely phenomenal because there's just more and more application for vehicle security, vehicle monitoring, and everything that goes with that in terms of efficiencies that software can drive for you. So pretty smart stuff. Well worth looking up and reading what they're up to. And again, from an IoT perspective, cloud-based infrastructure is very smart, lean company. They have hardly anyone that works there, but what they get done is absolutely brilliant. So well worth a look. So this is Andy's model, or the team's model. It starts at the top with a very weird-looking, sort of, what is that? Is it a quaver? I don't know. I'm not a musical guy, but that weird-looking, sort of musical note-looking thing with the kickoff phase. The one thing I'll call out on this model immediately, it goes through the circle. The circle is essentially, it's like an Ouroboros. It's never actually expected to end. You just keep, processing through as you add and as you adjust, and as things change, you adjust within them. But again, you look at the principles are the same as what we say from the industry broadly. Define, right? So look at the device, define, what's going on in there, what's required. Perform the discovery, so validate what's out there, validate what we need from those, validate any exceptions at this phase, right? So if there's things that are not going to be done, those have to be called out in here. You then implement, so actually put these in play, start working with them, get your first bits of telemetry back, make sure you're getting what you expected, and take care of what you're not. Go to monitor. At this point, you're running the infrastructure. It's a monitoring phase. At this point, you're at the stage now where you're running. You kind of expected everything's running as it's supposed to be. And what now happens is if we have anything that's off the rails here, that gets interesting, right? Enforce. So any problems that occur, we have to obviously enforce. How we're going to operate around those. Apply any strictures that are needed at this point, right? Recover, so once an incident's occurred, once that device or that device series is problematic, has been isolated, is now able to come back on, how do we recover it? What is the process to validate that it's clean and it's going to come back in and perform as expected again, etc. Refine, right? So take the learnings that we've had from this process to that up to this phase, document the refinement, spread it out through the rest of the industry so that everyone knows. So if Cadillac Fairview's tower in downtown Toronto experiences an issue from an IoT perspective of one device type that caused them some issue, that the rest of the industry know through that process as well. Really clean, very clever, very good. And then back to the start, right? So that wheel just keeps turning. What are your thoughts? As a model, something you guys would think would be interesting?
Really good, Gary. I'm struck by this in the simplified operational model is kind of sort of following the NIST pinwheel.
Of course,
right?
yeah. Oh, very much, yeah.
Then my question is sometimes he's kind of like mold in the house. It kind of grows under the radar from a compliance point of view.
Yeah.
I don't see a lot of control profiles in NIST or ISO or maybe FIPS. Care to comment on?
Yeah, so back to the point about the 50 billion devices, the biggest problem with IoT is people consume and then think about, I wonder if I should be doing something about the security of this. Oh, this is good for me and my household. I wonder if my kids will be affected by this. I wonder if this is going to be an attack vector for someone. We literally, so I'll give you a great example. A company called CDW in Toronto did a great example of how simple this is to do. They had someone pick literally a square grid in a neighborhood. They sent then a guy to go and war drive the neighborhood. And with a camera crew from CTV actually just showed, they literally recorded the guy driving down the road, picking up a scent, you know, like basically got an electronic footprint of a house, hacked the Wi-Fi, hacked the door, hacked the cameras, and it was like 13 minutes. That's the problem. That's the example. So I would posit, like, I'm the positive example because I'm a security person. It's my mindset. Before the Ring camera got installed, I knew what the operating parameters were, what the update cycle is like, what's required, what communications it needs. Then it goes in. Most of the world goes the other way of like, cool, a Ring camera, you know, so when I'm not there, the Amazon guy, I can see him deliver the package. Or if someone rings the bell and I'm in Jamaica right now, great, I can see who it is and let them in or not. That's, you know, use first, think later is the problem with IoT completely. Yeah. And so that's when any model that accounts for this is useful. Yeah. But yes, to the NIST point, I actually had this conversation with Adam outside on the attack side. There's not enough understanding and structure and call out of, from an industry perspective, of how we get our arms around this and structure it for individual functional pieces. Yeah. Cool. We're on questions now, so good timing. Anybody who needs to converse further, we can do it right now as questions and answers. Otherwise, you know, hit me up on LinkedIn. I'll answer questions all year. I literally answered a question a couple of weeks ago from something I said last year, so appreciate the input, and let's have some questions. Please.
I'll take a break.
Thanks, Brendan. Oh, there we go.
Thank you for a wonderful presentation. I am not an IT geek, so I'm not sure if my question is, well, IoT.
Great.
So I see these instances when you're trying to create an account and they ask you to link, say, to your Gmail, and me being lazy and not wanting to have too many passwords. Is that IoT? Is it safe? Is it a good thing to do or not?
It's not IoT, but it is a general security principle where password complexity is something that you should maintain, right? Because that's one of the things that's in your hand to protect what you own and have. So when it comes to, you know, creating a password for use of an application or a function like email, etc., the more complex your password will be, the theory is the greater your, you know, the greater the time that will be required to hack it and break it. There are some password managers that people recommend. I've found personally, you know, and 1Password is a Canadian company that's had a history of issues now, of failings. There are password management functions you could look at that can do some of that for you and keep those passwords, and you can then call them as needed. There is also the ability, if you think about the way that you could create a mnemonic that's personal to you, I'll just give you an example which is completely fake, so please, you know, don't go after my Gmail account after this with it. But if I say like, hey, I'm interested in diving, I like the Caymans, and yesterday I dived Royal Palms Ledge, Royal Palms Ledge. I could make a password out of that using capital letters, numbers, and symbols such that it would mean to me that on that date I dived this thing, and I can use that as many characters essentially as I would like. That would be very hard for someone to figure out and guess, right? So I run a system like that where I have a series of passwords, all of which are unique and individual, but all of them have some meaning to me, and then it's a question of just keeping the gray matter functional to keep it together. Yeah. Does that answer your question? Close enough? We can talk some more after. Yeah, please.
Okay, I have an Alexa at home.
Yes, good.
which makes me very nervous when I'm chatting and I'm seeing the little light go off.
Yeah.
And it makes me then even more paranoid when I'm in the office. You're in a place that's meant to be confidential, but I've got a phone, but my Siri's listening. I've got a watch that
Yeah.
my Siri's listening. How paranoid do we need to be?
So the answer is very paranoid. Absolutely. Like, I would caution that you have to expect, with technologies like these that you're describing, you have to expect that your information is exposed. And I think that's a sound principle to start from, right? I mean, I think everyone in the room has probably had the example with their iPhone where they think, oh, that looks like a budgie. And then tomorrow I'm, fire up Instagram and suddenly there's budgie feed. And I'm like, what the hell? I just mentioned that word once, in passing, and now I'm suddenly getting this information. There's legion examples of how these things affect our lives. Not necessarily in a nefarious or a bad way, but they potentially could be.
Yeah. How do you secure your office environment when everyone has one of these?
You have to have infrastructure in the office that understands every device, every communication path, and what is sanctioned and not. You then take the unsanctioned and you essentially just send them out the front door, right? Everything within the infrastructure needs to be locked down so that those unsanctioned devices can't communicate internally, right? That's step one. And as far as devices go, if you want to have an experience with a device that's not going to listen to you and give you the budgie feed update tomorrow, you'd have to look at either locking that down to basically make it unfunctional, or looking at something like the unplugged devices that are coming online now, where they're specifically built so that there is no tracking there's no possibility of tracking in those devices. But you limit your capability and your function. Like your watch is gone, forget about that. You have to then give up and understand what you're going to be sacrificing. Thank you, that was good. Please.
Okay, so my entire home is smart. Almost everything in my home is smart, except the dog. So and to your point, where we go and we see stuff on Amazon that is cool and it has a function. So I bought this little switch, smart switch, to be able to reboot my Habitat, in the event that it hangs and stuff. And so I set this thing up, and then I went to look at the features of it, and then I noticed that this thing is advertising my public IP, and I ripped it out. Yeah, I'm guilty of that. Yeah, it's supposed to be IT security. I should know better. But that being said, the one thing that struck me is that over to the corporate side now, we should be purchasing, or our procurement policies should be driving, and the standards, our standards for IoT devices should be driving our procurement policies for getting them.
Absolutely.
Which means that we shouldn't be bringing stuff into our corporate environment that we don't absolutely understand.
Of course.
How they work.
Yeah.
It seems obvious seeing it here and after your presentation.
It's incredibly difficult for people to get right, because at the end of the day, time and security are always in contention, right? And if it's going to take me time to secure the things properly, inevitably someone from up top's coming down saying, hey, just move it along, get this thing going. I'll give you an example. I can't name the company, but there's a chip manufacturer that everybody in this room probably would remember from history but doesn't know currently, that operates in the US. I was lucky enough to have a conversation with their architects last year, and they described how they operate. So in their environment, not one single thing that anybody could walk into that building can communicate out. So everyone has a locker outside. They come in, they leave the stuff there, and every communication within that building is completely understood and locked down. So like if you took a device in there, even if you could get a device in, and you try to get it connected, or you try to connect to anything else, it is going to go nowhere. But they've got 30 years of building that practice and that experience and having that hard, theory of how they want to operate and living it. That's the exception. Most organizations are rife with problems. That's where guys like RJ and James come in and do analyses of different infrastructures, and there's problems all over the place because these are common issues for everybody. Please, there's one at the back there. And one in the middle. Yep, we're going to go at the back first. Just one sec.
Am I the back?
Yeah.
Maybe you could speak from your experience in regards to power utility companies.
Yes.
The Cayman Islands is about to seriously ramp up its layout of solar, both for households and utility scale.
Good.
Now, a lot of these houses that have had solar on them for maybe 20 years have been using what I'll just call bespoke management systems for the solar.
Yeah.
It's important that the regulator here and the local power company CUC communicate with each other to understand if there's standards for these management systems on houses. And the risk there is in regards to frequency control from the main utility. Because if you've got a street or if you've got a development with 100 houses on or 50 condos on, and you're all using the same solar power systems with the same control modules, say from China or something,
right,
and it gets attacked or it goes offline, you can have a major pump or a major drop in the frequency levels or power requirements from CUC, and they're going to have a real problem with that.
That scenario is the one that keeps a lot of people, not only in critical infrastructure, but in federal government, like in top-level government, awake at night, because the legions of the attackers that are referenced, a lot of what their task is to map out all those things, get some sort of current, some sort of footprint in there that they can maintain and have it ready for when they need it.
So is anybody further ahead? Are there any defined approaches to looking at this?
I see entities that are ahead because they're hard structured on how they secure their technologies. Yeah, but those, again, it's convenience, it's operational, demands from the board and how they want to operate. It's time that goes into those. But you could look at like the Canadian as an example. Not that I've had current referencing on them, but I know, for example, the Canadian nuclear power infrastructures are amongst the foremost in the world in terms of their infrastructure for security and how they're operating. Yeah. So it can be done. It's hard and it needs ongoing monitoring and refinements. But yeah, it's doable. Thanks. Last one in the middle here.
It was just a question about, have you got a customer previously who was that much concerned about privacy as the question that we just got before?
About price, did you say?
Privacy.
Oh, privacy. Yes, absolutely. Yeah. So that's one of the reasons why we sometimes see a hard push on exceptions in securing IoT is where people's privacy comes into account, right? So, example, Canadian context. If there's a medical IoT device that'll record something on my behalf, right? So I walk around, I have a heart problem, I walk around for 2 weeks with a little monitor on me. I take that in, it records the data, they dump the data down. I don't have the ability to ask them that they clear the machine before the next person gets it. But from the Canadian legal context, what I do have is an expectation of the privacy for the life of me, the patient, for that dump of data that they just recorded. Privacy is an absolutely great lever, but it can go both ways, right? So it can be an exception or it can be an inclusion, depending on how things are seen. Yeah. Thank you. Well, I'm over time. Thank you all so much. Welcome to have a conversation outside if you need.